Am I audible? Am I audible? All right. So guys, good evening, good evening, good evening, and welcome back again to your Unacademy NEET English channel. I hope all of you are doing great, having a good time. What's happening here? All right, so let me know quickly, people, in the chats, if all of you can hear me, if I'm perfectly audible, visible to every one of you. Let me know in the chats. I know I'm late by 10 minutes. I'm sorry for that. Yeah. So let me know in the chats, people, quickly, if all of you can hear me, if I'm perfectly audible, visible to every one of you. Yeah. All right, people, all right. So as you all must be knowing, today it's going to be a very special session of your inorganic chemistry, right? I shall be discussing some 100 questions with all of you, okay? And my dear students, you can expect similar sort of questions directly, indirectly in your upcoming NEET examination as well, okay? And you know, inorganic, it is the most scoring subject. Questions are, like every year, questions come very, very, very easy from your inorganic chemistry part, particularly from your NCERT directly, right? So this year, again, it's same as expected. So if the chemistry paper is tough also, still inorganic level will remain the same, okay? For example, if NTA has made the chemistry paper tough, then they would have made physical or organic chemistry tough. Inorganic level always remains the same. Yeah? So all ready? All ready, people? I shall be sharing the PDF of this particular session, the handwritten PDF of this particular session on my Telegram. Okay? I'll let you know what is the Telegram channel name. Its name is Wassim Bhat Chemistry Official. WASSIMBHAT Chemistry Official is the name of the Telegram channel on which I shall be sharing the handwritten PDF. So what is the duration of the class? Duration of the class is going to be approximately 1.5 hours. Between 1.5 hours. Because inorganic solving does not take a lot of time, right? We don't have to solve things, correct? Okay. So before starting, so tell me which part of the country you guys are watching me from. I just want to know first. I just want to know first. Yeah. I just want to know first. Tell me quickly, tell me quickly. I might sound a bit low today. My throat is not in a good condition. Basically, it hurts when I speak. Yeah, so I might sound low. But you have got nothing to do with that. Yeah? You'll be focusing on the session. Okay, let me see first of all from where students have joined. Telangana, Assam, Andhra Pradesh, Karnataka, Kashmir, Bihar, Hyderabad. Okay, Andhra, Bihar, Kerala, Punjab, Mangalore, Kashmir, Hyderabad, Mumbai, Jaipur. Okay. That's great, people. That's great. Rajasthan, Arunachal, Madhya Pradesh, Pondicherry, Bikaner. All right. Perfect. So should we start then? All ready? Guys, basically, whatever questions I'll be giving you, you are going to give me the answer of each and every question in the chats. Okay? I'm not going to solve anything though. You will be providing the answers in the chats continuously. The chats should be continuously running in the today's session. The chats should be continuously running in the today's session, my dear students. Okay? Perfect. So, should we get going then? All right. Chalo, let's start the session, my dear students, with the first question that's on your screen. I'm pretty much sure every one of you would easily solve this question. They would easily tell me the answer of this particular question. So tell me the answer of this question. The IUPAC symbol for the element with atomic number 119. 119. What do you think about this question? I hope the options are visible to you. Atomic number 119. Atomic number 119. Majority is coming up with the correct answer. Majority is coming up with the correct answer. Absolutely. My dear students, it's your option number 2. Yeah? And majority was coming up with option number. Majority was coming up with option number 3. You need to be careful with these things. You need to be careful with these things, my dear students. So basically, it's 119. For 1, you use the term un. For 1, again un. For 9, you use en. Okay, n. Perfect. So it is basically UUE. That is going to be the symbol. UUE. It's not UUN. Right? These are the silly mistakes which you do in the examination hall. So you have to read the question properly. Okay? Then answer the question. Do not write the answers in the hurry. That's what I would want from you. Perfect? It's enium, basically. Got it? Moving on to the next one, guys. Moving on to the next one. What do you think about this one? The element Z is equal to 114. Atomic number of the element is 114. Has been discovered recently. It will belong to which of the following family, group, and electronic configuration? So what do you think? What do you think, guys? What do you think? The element with atomic number 114 has been discovered recently. In which group you are going to keep it? In which family you are going to keep it? So first of all, just do one thing. Look at the last 2 digits. Look at the last 2 digits. It's 14. So its group number is going to be 14. Its group number is going to be 14. And group number 14 means which family? It means you are talking about the carbon family. Right? Do we have any option with carbon family? Absolutely. Option number 1. So option number 1 is going to be the correct answer of this particular question. Okay? So these last 2 digits are going to talk here in this particular question. Okay? Now, my dear students, I am moving on to the next question. Look at the question carefully. Read the question and tell me its answer in the chats. And be quick. Be quick. Be quick, guys. An atom has electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 3d3, 4s2. You will place it in which group? You will place it in which group? Tell me in the chats quickly. Tell me in the chats quickly, guys. I have posted one video on this particular session as well. Like how do you check the group number? How do you check the period number, etc., etc. So basically, it's a D block element. As you can see, the last electron has entered into the D subshell. It's a D block element. And in case of D block elements, how do you check it? How many electrons do you see in this D? There are 3. Plus, how many electrons do you see in this S? 2. So 3 plus 2 comes out to be 5. Right? So the element belongs to 5th group. Group number is going to be, in case of D block elements, if I talk about the group number is basically n minus 1 D electrons plus ns electrons. Okay? So this was your basically ns. This is n minus 1 D. ns is having 2 electrons. n minus 1 D is having 3 electrons. So 3 plus 2 makes it 5. So the group number of the element is going to be 5. As simple as that. Okay? So the element belongs to 5th group. Okay. What about this one? This every one of you should be in a position to answer? Tell me, people in the chats. The element with atomic number 118 will be, is it going to be alkali metal, noble gas, lanthanide, transition element? Again, 118, look at the last two digits. It's 18. So its group number is going to be 18. Group number of the element is 18. So which elements belong to 18th group? They are the noble gases. So the element is going to be noble gas. It is going to be the noble gas, right? Simple. Perfect. Perfect. Perfect, guys. Next question on your screen. The correct order of the ionic radii of O negative, N negative, F negative, Mg positive, Na positive, and Al positive is. You have to give the order of the size. Well, first of all, if you look carefully, these are all the isoelectronic species. All are the isoelectronic species. All are the isoelectronic species. Remember, in case of isoelectronic species, when you have to compare size, it is inversely proportional to positive charge. More the positive charge, lesser the size. More the positive charge, lesser the size. More the positive charge, lesser the size. So this Al positive has got maximum positive charge, so its size will be least, followed by this, then option A is going to be the correct answer of this particular question as well. These are isoelectronic species. And in case of isoelectronic species, your size is inversely proportional to the positive charge. I believe this is also clear to everyone. And what do you think about this one? What do you think about this particular question, guys? What do you think about this particular question? Again, you should be in a position to solve this. You have to give the order of first ionization enthalpy. First ionization enthalpy. So lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So generally what happens? If I talk about lithium, then you have got beryllium, you have got boron, carbon, nitrogen, oxygen, fluorine, neon. Right? Right, my dear students? Generally what happens when you move from left to right in the periodic table? When you move from left to the right in the periodic table, what happens to ionization energy? Ionization energy increases. So what is the expected order? This is supposed to be the expected order. This is supposed to be the expected order. But in reality, is it going to be the actual order? In reality, this is not going to be the actual order. In reality, this is not going to be the actual order. Why is that? See, in reality, if you look at the order, in case of your beryllium, hydrogen, helium, lithium, beryllium, its outermost configuration is 2s2, right? Boron, its outermost configuration is 2p1. So 2s2 configuration is like this. This 2p1 configuration is like this, right? Do you see this completely filled, right? To take electron out from completely filled, you have to supply more energy. So ionization energy of beryllium will be more than that of boron. Ionization energy of beryllium will be more than that of boron. So ionization energy of beryllium would be more than that of boron. Number one. Number two, one more thing. Among nitrogen and oxygen, what is the outermost configuration of nitrogen? It's 2p3. What is the outermost configuration of oxygen? It's 2p4. If you look at 2p3 configuration, 2p3 configuration is half filled. It is half filled. 2p4 configuration, it is partially filled like this. 1, 2, 3, and 4. Correct? So 2p3 configuration, it's half filled, more stable. To take electron out from here, more energy is required. That's the reason why nitrogen has got more ionization energy than that of oxygen. So here comes nitrogen and here comes oxygen. So this is going to be the order. This is going to be the order. Now, do you see any option resembling this? Yeah? So what is going to be the correct option? The correct option is going to be option number 2. Got it? I believe everyone already gave the correct answer. Now, my dear students, moving on to the next one. The correct order of electron gain enthalpy. These are group 16 elements. Group 16 elements, right? O, S, Se, Te, right? And Po. Po is not given, so leave that. So these are group 16 elements. Generally, my dear students, when you move from top to bottom, what happens to electron gain enthalpy? Electron gain enthalpy decreases generally, right? Electron gain enthalpy decreases generally. Okay? So if I compare oxygen and sulfur, Oxygen should have more electron gain enthalpy than sulfur. Oxygen should have more electron gain enthalpy than sulfur. But oxygen, since its size is minimum, its size is less. In this group, its size is minimum. Because of the lesser size, its electron gain enthalpy, right, would be less. Got it? So oxygen comes at the end basically. Oxygen comes at the end basically because of its lesser size. Because of its lesser size. So I'll go with option number 1. That's the correct answer of this particular question. This is the correct order of electron gain enthalpy of your group 16 elements. Going on to the next one. Which one of the following arrangements represent the correct order of least negative to more negative electron gain enthalpy? Least negative to more negative. See, halogens will be having maximum negative here. Halogens will be having maximum negative here. Perfect. And as I can see, you have got calcium. It belongs to your second group. Perfect. Alkaline earth metals. They'll be having least. Halogens will be having highest. And your group second element will be having the least. So what is going to be the order? Order is in front of you. Quick. Guys, it's a very simple question. You should be solving this question on your own. Right? Absolutely. It's option number 1. Option number 1 is the correct answer. What do you think about this one? What do you think about this one? In which of the following options the correct order of arrangement does not agree with the variation of property indicated against it? So, Al tripositive, Mg dipositive, Na positive, F negative. Increasing ionic size. That's correct. More the positive charge, lesser the size. So this is correct order. Right? This is not wrong. Look at the next one. Boron, carbon, nitrogen, oxygen. Increasing first ionization energy. Is this right? Boron, carbon, nitrogen, oxygen. Increasing first ionization energy. Is this right? Is this right, people? This one is wrong. Few minutes back I told you, nitrogen has got more first ionization energy than that of oxygen. So this is wrongly mentioned here. This is wrong. So odd one out. So this is the correct answer. Rest all the things are correct. Chlorine has got more first electron gain enthalpy than that of fluorine. Right? Like I told you, sulfur has got more than that of oxygen. What about this one? What about this one? Again, this is a similar sort of question. Again, this is a similar sort of question. In which of the following represents the correct order of increasing electron gain enthalpy? My dear students, see, these are your halogens, group 17. This is your group 16. So, oxygen, sulfur, chlorine, chlorine, right? On moving left to right, electron gain enthalpy increases. On moving from top to bottom, electron gain enthalpy decreases, right? But you already know the exceptions. You already know the things here. Chlorine has got more than that of fluorine and sulfur has got more than that of oxygen. Right? So what is going to be the correct answer? So first it's going to be chlorine, then it's going to be fluorine, then it's going to be what? Which one? Quick. Then it's going to be sulfur and then it's going to be oxygen. So I'll go with option number 2. I'll go with option number 2. Option number 2 is the correct answer. Again, one important question. You can expect this sort of a question again. You have to match the following. Which of the following is neutral, basic, acidic, amphoteric oxide? Quick. Be quick, guys. Done? It's a memory-based one. So first of all, if you talk about Na2, Na2 is a basic oxide. Remember it directly. Al2O3, what is that? That is the amphoteric oxide. N2O, N2O, that is neutral. Okay, Cl2O7, that is your acidic oxide. Perfect. So which one is matching here? 1 with B, 2 with D, 2 with D, 3 with A. So it's option A. Option number 1 is the correct answer of this question. Moving on to the next one, guys. Moving on to the next one. Look at this one. Look at this one. Outermost electronic configuration of group 13 element is 4s2 4p1. All right. Okay. The electronic configuration of an element of the p block, period 5, placed diagonally to the element. Give it a thought. Give it a thought quickly. So if you talk about your group 13 is boron, aluminium, gallium, indium, and thallium, right? This is your 2s2 2p1 configuration. 2s2 2p1. This is your 3s2 3p1 configuration, right? This is 4s2 4p1 configuration. What is mentioned? I think same is mentioned, 4s2 4p1. So basically 4s2 4p1. So that means they are talking about gallium. Now we have to talk which element will come diagonally with gallium. So if this was group 13, what about your group 14? Group 14 will be carbon, silicon, germanium, tin, and lead, right? So these two are coming diagonally, right? So it's going to be tin. Now, what is the configuration of carbon? It's 2s2, 2p2. This is 3s2, 3p2. This will be 4s2, 4p2. This will be 5s2, 5p2. So the element that's going to be the answer, that's going to be tin, 5s2, 5p2. Look at the configuration, 5s2, 5p2. So it's option D, that's going to be the correct answer among all. Okay? Perfect. Majority has already given the correct answer, that's great. All right. Tell me, the set of elements that differ in mutual relationship from those of the other sets. Which of the following sets do you see somewhat different? What do you think? Think over it. Think over it, guys. I want you to think over it. Exactly. Majority is right. It's option D because these two are not diagonally related. All the others, lithium, magnesium, boron, silicon, beryllium, aluminium, they are diagonally related elements. Lithium, sodium, they are not diagonally related. You can check it out too. See, lithium, magnesium, diagonally related. These two are, right? And lithium, aluminium, lithium, sodium is not diagonally related. Lithium is diagonally related with magnesium, basically. Okay? Perfect. Moving on to the next one. What do you think about this one? Simple. Simple, guys. What do you think about this one? Yes, Abhinandan, I'll do that. Don't worry. The property that shows an opposite trend in comparison to other properties across the period. So across the period, electron negativity increases. Across the period, electron gain enthalpy also increases. Ionization energy also increases. Across the period, size decreases. So which one is showing opposite trend? So it's atomic radius. Right? Tell me the answer of this one. Don't make it wrong now. Don't make it wrong. It is nil onium. Nil onium. Nil onium. Un is 1, nil is 0, un is 1. So 101. Option D. What do you think about this one? The element with atomic number 120, not yet discovered, will be transition metal, inner transition metal, alkaline earth metal, alkali metal. What do you think? Quick. Again, majority are given the correct answer. It's alkaline earth metal. Why is that? Atomic number 118. If I talk about atomic number 118, its group number is going to be 18. Group number 18 means it's a noble gas. It's a noble gas. Now, 119 will go to the first group. 120 will go to the second group. Second group is called as alkaline earth metal, right? So it's an alkaline earth metal for sure. Now, what about this one? The group number, number of valence electrons and valency of an element with atomic number 15. It's simple only, right? Atomic number 15. Which element this is? Atomic number 15. Which element this is? Atomic number 15, guys. Quick. They are talking about phosphorus, right? Now talk about phosphorus. What they are asking? They are asking about the group number. Phosphorus belongs to 15th group. Group number is 15, right? Valence electrons, which phosphorus has? 5 valence electrons. Valency, 3, right? 1553. That is the correct answer. 1553 is the correct answer. 1553 is the correct answer, yeah? Okay. I believe this is clear. Okay, moving on to the next question. What do you think about this one? In general, the properties that decreases and increases down the group in the periodic table. That decreases and increases. Decreases, first one should decrease, second one should increase. Down the group. See, if you talk about electronegativity, down the group electronegativity decreases, right? Down the group atomic radius increases. That decrease and increases. Is that what they are saying? The properties that decrease and increase down the group. So it's A only. Nothing difficult or something. What about this one? What about this one? N trinegative, O dinegative, F dinegative. You have to talk about their size basically, right? Then you can compare the values. This one will have maximum size, right? Maximum size. Perfect. Yeah. More the negative charge, more the size. So among these three, this will have least size, right? So it's option C. That's matching it. Absolutely. Majority is right. Great. Great, great, great. Okay, look at this one. Again, a simple question. Asked in your JEE mains too. The first ionization potential of sodium is 5.1. The value of the electron gain enthalpy of Na positive. Just reverse the sign. It's going to be minus 5.1. Simple. Right? What about this one? Which of the following has got the maximum unpaired electrons? Maximum unpaired electrons. Which one do you think? If you look at this Fe positive, iron has got the configuration of 3d6 4s2. 3d6 4s2. So take 2 electrons out. When you take 2 electrons out, it becomes 3d6 4s0. Now look at 3d6 configuration. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and 6. There are 4 unpaired electrons. 4 unpaired electrons. In all the other cases, you won't find 4 unpaired electrons. So it has to be option D only. Yeah, it has to be option D only. People are saying option A. How come it's option A? Maximum unpaired electrons, they are saying. Maximum unpaired electrons, they are saying. Chalo. Moving on to next one. The hydration energy of Mg dye positive is larger than? Hydration energy is directly proportional to positive charge. Hydration energy is directly proportional to positive charge of the cation, right? More the positive charge, more the hydration energy. More the charge, more the hydration energy. So hydration energy of Mg di positive will be larger than which one? It will be larger than Na positive. It will be larger than Na positive. Right? It will be lesser than Al tri positive because Al tri positive got more charge. Okay, next one. The correct order of second ionization potential. They are not talking about the first one. They are talking about the second one. Second one. So carbon, nitrogen, oxygen, chlorine, right? So what is the outermost configuration of carbon? It's 2s2, 2p2. Perfect. If I take the first electron out, that is the first ionization potential. I will take the second electron out. I will take the second electron out. So this configuration will be 2p1 basically. So I have to take the electron out from this configuration. Then I talk about the second ionization energy. Nitrogen. Nitrogen's configuration is 2p3. Now take already one electron out. So I have to take the second electron out from 2p2 configuration. Oxygen. 2p4. Take one electron out. So I have to take electron from 2p3 configuration. Right? And this is 2p5. So I have to take the electron out from 2p4 configuration because I'm talking about the second ionization energy. I'm talking about the second ionization energy. So if you look at this particular configuration here, it's half-filled configuration, more stable. To take electron out from here, more energy is required. So second ionization energy of oxygen will be maximum. Second ionization energy of oxygen will be maximum. Right? Perfect. Now which one is the correct answer? Quick. Quickly, people. Quick. Absolutely. It's your option number C. Okay, moving on to the next one. Tell me quickly the answer of this one. Na positive radius is given. The ionic radius of Mg di positive and Al tri positive. So Al tri positive will be having lesser than this. Even Mg di positive will be having lesser than this. Right? Al tri positive will have least value. Al tri positive will have least value. So what is going to be the correct answer? Quick. It's a simple question. You should be in a position to solve this. Quickly, people. Perfectly done. Absolutely. It's your option number 2. It's your option number 2. Tell me the answer of this one. Tell me the answer of this one. When a metal atom combines with a non-metal atom, the non-metal atom will, what metal does? Metal loses electrons, right? Metal loses electrons, gets converted into cation, right? Non-metal atom gains electron, gets converted into anion. So non-metal atom will gain electron and its size will increase, right? Because it's forming the anion. So gain electrons and increase in size. Simple. Tell me, which of the following does not represent the correct Lewis structures? See, carbon has got 4 valence electrons and over here they have mentioned 4. Oxygen has got 6 valence electrons. Here they have mentioned only 5, so this is incorrect. Neon, 8 valence electrons and here they have mentioned only 6, incorrect. Beryllium, 2 valence electrons, shown 2 valence electrons. Boron, 3 valence electrons, they have shown 2 valence electrons. 3 valence electrons. So these two are incorrect, 2 and 3. 2 and 3 means I'll go with option number D. Yeah, I'll go with option number D. Next one. For John's rules, covalent bond is favored by smaller cation, larger anion. Covalent bond is favored by smaller cation, larger anion. Polarizability of anions. Polarizability of anions is directly proportional to size of anion. Polarizability of anion is directly proportional to size of anion. Right? So more the size, more the polarizability. So I would say I negative will have maximum size. So I negative will have maximum polarizability, followed by this, followed by this, followed by this. So it's option A. Yeah, it's option A. Okay, what about this one? Covalent character, basically. Order of covalent character. What do you think? Order of your covalent character. What do you think? Again, you'll have to use Pajan's rules only. There are a lot of videos which are posted on Pajan's rules. I hope you know. A lot of videos which are posted on Pajan's rules. Quick. See, it is Li positive, Cl negative, Be di positive, Cl negative, boron tri positive, Cl negative, carbon plus 4, Cl minus 1. So anion everywhere is same. It's Cl negative everywhere. So I cannot decide on the basis of Cl negative. I'll have to decide on the basis of cation. More the positive charge, more the charge on cation, more the charge on cation, more the polarizing power of cation. And if more is the polarizing power of cation, more is the covalent character. So this is the order of the covalent character. Majority is right. Great. Okay. What about this one? Similar sort of question. Similar sort of question, guys. Similar sort of question. Tell me its answer. So it is basically Pb di positive, Cl negative. Pb di positive, F negative. Pb di positive, I negative. Pb di positive, Br negative. So don't decide on the basis of Pb di positive. Decide on the basis of the anionic part. Right? So what do you think? More the size of anion, more the polarizability of anion. And more the polarizability means more the covalent character. So this will have maximum covalent character. Right? Okay, I have to talk about decreasing ionic character. Decreasing ionic character means increasing covalent character. Decreasing ionic character means increasing covalent character. So third will have maximum covalent character, right? So minimum ionic character. Got it? They're asking about the decreasing ionic character. Decreasing ionic character means increasing covalent character. Yeah? So your correct option is option number D. What about this one? What about this one? What about this one, people? Most ionic and most covalent you have to select. Most ionic means less covalent. Most ionic means less covalent. Right? So technically you have to select less covalent and most covalent. Less covalent and most covalent. Chromium here will be in +6 oxidation state. Manganese here will be in +7 oxidation state. Lead here will be in +2 oxidation state. Manganese +7. Right? Chromium +6. Iron +3. Chromium +6. Tin +4. Right? So more the charge on the cation, more the polarizing power of cation. More polarizing power means more covalent character. So more covalent character will be for definitely Mn2O7, right? Less covalent will be this one. I'll go with option B. I'll go with option B. Right? Moving on to the next one. Similar sort of question. Tell me the answer of this one. Similar sort of question. Quickly. Quickly, guys. Increasing order of covalent character. So definitely this will have maximum covalent character because it's Al tri positive here. This is magnesium di positive. This is Rb positive. This is Na positive. So more the positive charge on the cation, right? More will be the covalent character. So AlCl3 will have maximum covalent character. AlCl3 will have maximum covalent character, followed by MgCl2. followed by MgCl2. Now, among these two, lesser the size of cation, more the covalent character. So 1 and 3. Okay? So I'll go with option number C. Okay. What about this one? What about this one, guys? Which of the following set of molecules will have zero dipole moment? Quick. Quickly, guys, everyone. So they're talking about the zero dipole moment, right? Zero dipole moment. It's going to be your option number C. Yeah? It's going to be your option number C. BF3. BF3, right? If you look at the structure of your BF3, this is the most common molecule, you know it, right? Less electronegative to more electronegative, less to more, less to more. Perfect. So net dipole moment here will be 0. Perfect. Similarly, you have got BEF2. 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 Less electronegative to more, less to more. Again, cancels out. So net is 0. Net is 0. Carbon dioxide. Carbon dioxide. Again, net will be 0 because linear. Less to more, less to more. So net here is 0. And similarly, 1,4-dichlorobenzene, it will be already having 0 dipole moment only. Yeah? So option C is the correct one. What about this one? So basically, more the electronegativity difference between the atoms, more is going to be the dipole moment. In short, right? So H2O, electronegativity difference here is maximum, so it will have maximum dipole moment, followed by NH3, NF3, and BF3. BF3 is eventually I'm going to have zero dipole moment, minimum dipole moment, right? Which of the following is a polar molecule? Which of the following is a polar molecule? Remember one thing. Whenever you see the molecule of the type AB2L0, AB3L0, AB4L0, AB5L0, AB6L0, right? Similarly, AB7L0. Similarly, you have got AB2L3 or AB4L2. AB4L2. These are the molecules which have got net dipole moment 0. And that particular molecule whose net dipole moment is 0, you call that as non-polar molecule. Apart from all these, they'll be polar molecules. Apart from all these, there'll be polar molecules. All these are non-polar. Now, if you look at SF4, sulfur. Sulfur is the central atom. How many valence electrons it has? 6. How many sigma bonds it's forming? 4. So out of 6 valence electrons, 4 are being utilized to form 4 sigma bonds. So there'll be 2 electrons left as such on sulfur in the form of a lone pair, right? So the type of the molecule is going to be A, it's going to be B4L1. AB4L1. Is AB4L1 in this category? No. So it's a polar one. It's a polar one. Its net dipole moment will be zero, will be non-zero. Okay? What about this one? Similar sort of question. Similar sort of question. Quick. Which of the following possesses dipole moment? So you have to see net dipole moment non-zero. Majority is coming up with the option number C. Absolutely, you guys are perfectly right. It's option number C only. Great. Which of the following represents zero overlap? See, do you see same sign on same side? Same sign, same side means positive overlap, right? Opposite sign on same side means negative overlap. Do you see any overlap here? No. Right? So it is zero overlap in C. The molecule not having any pi bond. The molecule not having any, you already know it. It is Cl2, O2 looks like this, N2 looks like this, and carbon dioxide looks like this. So which one does not have any pi bond? It's Cl2. Simple. Yeah? It's Cl2. Very simple one. This is your asked question in your NEET. Do you see this? Tell me the answers in the chats, quick. Every one of you. At least this everyone should know. So sp2, sp2, sp, sp, right? See, this is forming 3 sigma bonds, so sp2, 3 sigma bonds, sp2, 2 sigma bonds, sp, 2 sigma bonds, sp. So it's option B. That's going to be the correct one. Right? What about this one? ASF5. 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 So your arsenic is a central atom. How many valence electrons it has? It has got 5 valence electrons. How many sigma bonds do you see? 5 sigma bonds, right? Will there be any lone pair? There will be no lone pair, right? Steric number will be sigma plus lone pair, that's 5. Hybridization is going to be sp3d. And in sp3d hybridization, which all orbitals are involved in the hybridization? It's s, it is px, it is py, it is pz, and it's dz square. Right? So it's option C. That will be the correct one. Perfect. In which of the following molecule all the bond lengths will be same? Quickly, in the chats. Guys, everyone, I want the answers in the chats. See, the type of this molecule is AB4L1. This is AB5L0. This is AB4L2. In case of AB4L2, all the bond lengths will be the same. Remember it. Okay? What about this one? In case of water, the bond angle should be 109 degree 28 minutes, but in reality it's 104 degree 5 minutes. Why is that? Because of lone pair repulsions, bond angle decreases, right? XCF2 is isostructural with. XCF2 is isostructural with. First of all, XCF2, what is the type of the molecule? XEF2, the type of this molecule is Ab2L3, right? So do you see any molecule of the type same? This ICl2 negative will have the same type, Ab2L3. So if the type is same, they are going to be isostructural. If the type is same, they are going to be isostructural. Okay? What is not applicable to TeCl4? What is not applicable to TeCl4? How many valence electrons this tellurium has? 6. How many sigma bonds? 4. How many lone pairs on tellurium? 1. Right? Steric number? 4 plus 1, 5. Hybridization? sp3d. Type of the molecule? Ab4L1. Ab4L1 is seesaw shaped. I wrote all the things about this. Now check. Which is not applicable. See, seesaw shape, applicable. Tetrahedral in shape, not applicable. 4 bond pairs, 1 lone, 4 bond pair, 1 lone pair, applicable. sp3d, applicable. So option B, right? Option B. Identify the wrongly matched pair. Identify the wrongly matched pair. NH3. NH3 is of the type Ab3L1. I hope you know how to check the type. PCl5 is Ab5L0. Right? SF6 is Ab6L0. And BeCl2 is, it is simply linear, you know it. BeCl2 is linear. SF6 will be octahedral. Right? NH3 will be quick. NH3. Ab3L1. It is pyramidal, correct. PCl5, Ab5L0, it's trigonal bipyramidal. Here they are mentioned that trigonal planar. So this is incorrectly matched. So it's option 2, which is incorrectly matched. Perfect. Great. In xenon, in XeOF4, what is the hybridization? XeOF4. Xenon has got 8 valence electrons. How many sigma bonds it's forming? 5. How many lone pairs will be on xenon? 1. Steric number? 5 plus 1, 6. Hybridization? sp3d2. Option C. Got it? Identify the correct hybridization. Identify the correct hybridization. Quickly. NO2 negative. NO2 negative. Nitrogen. How many valence electrons? 5. There is a negative charge, so add it. So 5 plus 1, 6. How many sigma bonds? 2. Right? How many lone pairs? 1 lone pair on nitrogen. Steric number? 2 plus 1, 3. Hybridization sp2. NO2 positive. How many valence electrons on nitrogen? 5. Subtract this positive charge, so 4. Sigma bonds 2. Lone pair 0. Steric number 2 plus 0 is 2. Hybridization is sp. And NH4 positive, all of you would be already knowing it's sp3 hybridized, right? So check the options. sp2, sp, sp3, right? So basically the molecule that's given to you is ClF3. They're asking us which one of the following is most stable. ClF3. The type of the molecule is Ab3L2. Ab3L2 is T-shaped molecule. So it's T-shape, it's the most stable shape. So where do you see the T-shape? Here I can see the T-shape. So this is the most stable one. This is the most stable one. Right? One tricky question. What do you think? Quick, guys. There are no 0 degrees. Okay, I'm keeping this to you. Tell me its answer. Tell me its explanation in the chats, in the comment section, Tell me its explanation in the comment section. Which of the following is not expected to exist? Quick. My throat is in very, very, very bad condition. Which one, guys? You should know this question as well. Any species with bond order 0, right? That does not exist. So BE2. Its bond order is 0, right? If you look at its molecular orbital configuration, it's sigma 1 is 2, sigma star 1 is 2. So antibonding electrons are 2, bonding electrons are 2. And how do you calculate bond order? Half of electrons. Number of electrons in bonding minus anti-bonding. So the value comes out to be 0. And if bond order is 0, that means the molecule does not exist. Okay? Which of the following is paramagnetic? Which of the following is paramagnetic? Quick. If you write the molecular orbital configuration of O2, you'll find 2 unpaired electrons. 2 unpaired electrons means paramagnetic. This is O2. In your molecular orbital configuration of O2, there are 2 unpaired electrons. One in pi star 2px, one is pi star 2py. 2 unpaired electrons means paramagnetic. The number of anti-bonding electrons in O2. Again, number of anti-bonding. In order to calculate the anti-bonding electrons, you should know the molecular orbital configuration. See, these are the 2 anti-bonding electrons. 2 plus 2 is 4. 4 plus 1, 5. 5 plus 1, 6. So there are 6 anti-bonding electrons. There are 6 anti-bonding electrons in O2. Right? Okay, when O2 gets converted into O2 negative. O2 into O2 negative, right? So basically you are giving 1 electron to O2. That 1 electron goes to where? That goes to pi star 2px. That goes to pi star 2px, right? You just saw the molecular orbital configuration. Which of the following molecules only have pi bonds? This is the famous question C2. In C2, the bond order is 2 and both the bonds are pi bonds. Okay? Both the bonds are pi bonds. Which of the following species have same bond order? Isoelectronic species have same bond order. See, CO, 8 plus 6, 14 electrons. 7, 6, 13 plus 1, 14 electrons. So these two are isoelectronic, their bond order will be same. And their bond order will be 3. 14 electron species, they have bond order 3. The common feature among Cn negative, CO and NO positive. I think these are also isoelectronic. They have same electrons, isoelectronic, their bond order will be first of all same. Their bond order will be same. And since they are 14 electron species, all of them, 14 electron species of bond order 3. So this one is correct. This one is correct. Bond order. O2 is 8 plus 8, 16 electron species. O2 negative is 17 electron species. O2 positive is 15 electron species. O2 negative is 18 electron species. Now you know, 14 electron species will have bond order 3. 15 electron species has got bond order 2.5. 16 electron species has bond order 2. 17 electron species has bond order 1.5. 18 electron species has got bond order 1. 13 electron species 2.5. 12 electron species, 2, 11 electron species, 1.5, 10 electron species, that is 1. So O2 is a 16 electron species. Its bond order will be 2. O2 negative is the 17 electron species. O2 positive is the 15 electron species. And O2 di-negative is the 18 electron species. Now arrange them on the basis of their bond orders. Okay. Guys, there are more questions left, but I'm not able to speak. My throat is in bad condition, right? It hurts while I talk. So I'll share this PDF in my Telegram. If you are not the part of the Telegram channel, be the part, and you can solve the rest of the questions on your own in the today's session, because I'm really not able to speak properly. It really hurts while talking. This is the name of the Telegram channel, okay? My throat is actually in very, very bad condition. You have no idea. It hurts a lot while talking. But don't worry, I'll share this complete PDF. The rest of the questions you can check on the Telegram, right? This is the Telegram channel on which I shall share, okay? And there'll be more sessions coming. There'll be more sessions coming. And tomorrow I'll post a video wherein I'll tell you what all more sessions, like more conceptual sessions, more question solving sessions, everything. I'll let you know in that particular video, okay? Hello guys, you take care with this, huh? I'll take a leave with this.